Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will go to the third solved problem 3.4.10 solved problems. Third problem. The problem is show that determinant 1 a square a cube 1 b square b cube 1 c square c cube is equal to a minus b into b minus c into c minus a into ab plus bc plus a. This is our given problem. In this problem, we have to show this determinant value is equal to the RHS value. This problem is also we solve by using the operations. That is, first take the LHS. LHS equal to determinant 1 a square a cube 1 b square b cube 1 c square c cube determinant. In this is R1, R2, R3, C1, C2, C3. In this problem, we have to use the row operations that are for that first R1 is going to be, the first operation is R1 is going to be R1 minus R3 or R2, R1 minus R2, and R2 is going to be R2 minus R3. These two operations applied. First operation is R1 is going to be R1 minus R2, R2 is going to be R2 minus R3. For that is equal to determinant R1 minus R2 means the each corresponding elements would be subtracted. 1 minus 1 value 0. A square minus b square. Here a cube minus b cube. In second row R2 is going to be R2 minus R3. That is also 1 minus 1 value 0. B square minus c square. B cube minus c cube. 1 c square c cube. This is already we know a square minus b square value and also a cube minus b cube value. That formulas are substituted in this step. That is determinant 0. A square minus b square value is a plus b into a minus b. A cube minus b cube value is a minus b into a square plus ab plus b square. This is a cube minus b cube value. Similarly, here also we substitute the same formulas. 0 b plus c into b minus c into b minus c into b square plus bc plus c square. Last row is 1 c square c cube. This is the value. In first row we had to common a minus b, because 0 into a minus b value 0, then this value nothing change. Then from first row we have to take a minus b as common, and second row we have to take b minus c as common. Then that is equal to a minus b in first row, b minus c in second row. Determinant 0, a plus b, a square plus ab plus b square. 0 b plus c, b square plus bc plus c square. 1 c square c cube. That is equal to in next step we have to take another operation, that is R2 is going to be R2 minus R1. We have to apply the operation for second row. Then that is equal to a minus b into b minus c. Determinant here R2 minus R1. First row is same. 0 a plus b, a square plus ab plus b square in second row 0 minus 0 value 0, b plus c minus of a plus b. That means b plus c minus a minus b. Plus b minus b get cancelled, then c minus a. Here b square plus bc plus c square minus a square minus ab minus b square. Here plus b square minus b square get cancelled, then the remaining value is bc plus c square minus a square minus ab. In third row 1 c square c cube. Determinant that is equal to a minus b into b minus c. Determinant 0 a plus b, a square plus ab plus b square, 0 c minus a. Here in these two, first we have to take these two values. From these two we have to take b as common, b into c minus a, plus from these two terms c square minus a square means a square minus b square formula, a plus b into a minus b. From that c plus a into c minus a, we have to write down the below 1 c square c cube. This is here c minus a is common. From this term and this term we have to take b as common, then the remaining values c minus a. In this we have to apply the a square minus b square formula, that is a plus b into a minus b, that is here c plus a into c minus a. From these both values, two terms, we have to take c minus a as common, then the remaining value is, then that is equal to a minus b into b minus c. Determinant 0 a plus b, a square plus ab plus b square, 0 c minus a. Here both take c minus a as common, then first from first term b is plus c plus a, 1 c square c cube. That is equal to a minus b into b minus c. From second row c minus a is common, taking common c minus a. Determinant 0 a plus b, a square plus ab plus b square, 0 1 a plus b plus c. b plus c plus c is nothing but a plus b plus c, and c 1 c square c cube. Determinant. Here we expand the determinant, then that is equal to a minus b into b minus c into c minus a, the determinant value. By using the first row, we have to determine the determinant 0 into. So first column would be deleted. This modulus value is calculated 1 into c cube minus c square into a plus b plus c. First term. In determinant, second term will be minus of, that is minus of a plus b into this column, this row would be deleted, 0 into c cube 0 minus 1 into a plus b plus c, a plus b plus c. This is second term. You have to write down the third term in the below, plus a square plus ab plus b square into this row. This column would be deleted, 0 into c squared 0 minus 1. This is the determinant value. Then that is equal to a minus b into b minus c into c minus a. This value is 0 into anything value is 0. Then 0 minus a plus b into 0, a plus b. Then here first value 0. Next a plus b into this value, minus into minus plus a minus b into a plus b plus c. That is a plus b into a plus b plus c plus a square plus ab plus b square into 0 0 minus of a square plus a square plus ab plus b square. This is the determinant value, that is equal to a minus b into b minus c into c minus a into 0. All values are 0. Here we have to multiply these two values, a plus b into a plus b plus c. First we have to multiply this a plus b plus c with a and plus a plus b plus c with b. A into a square plus ab plus ac plus next we have to multiply b. ba plus b square plus bc minus of a square minus ab minus b square. This is the value. Here plus b square minus b square get cancelled, and also plus ab minus ab get cancelled. That is equal to a minus b into b minus c into c minus a into here also a plus a square minus a square also get cancelled. Then that value is BA is nothing but AB plus BC plus CA. You have to write down in the order, that is equal to RHS. This is the RHS value. Then here we have to cancel the opposite terms. Then the remaining value is AC plus BA plus BC. Then but we have to write down in the order, that is AB plus BC plus CA, that is equal to RHS value. By using LHS we have to derive RHS. Hence we have to prove the solution of the third example problem in the solved problems 3.4.10. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.